Now on stage we have... oh, dan mag het Nederlands nu, hè?
Yeah, you can do unless we have English listeners in the public, I don't know.
Yeah, we have two people from abroad. Yeah, they don't speak Dutch. So,
no, so let's keep it in English then.
Yeah, okay.
Yeah, okay.
Now on stage we got Verpakken in Schimmels. And Jan, stage is all yours.
Yeah, thank you. Let me see first how this works, probably. Yeah, so packing in fungi. Usually people do not really have a nice fuzzy feeling when they hear there's molds around. But in our case, yes, it's a good thing. Because we provide an alternative for styrofoam. Not sure if I need to explain to you what the consequences of styrofoam are to this world. I'm going to keep that extremely short. Literally, I stop here. Let's talk about the alternative, which is packaging made with fungi. What you see here is, on the right side, the cap of a mushroom. So that mushroom cap, when you take that from the woods, you put it on a white piece of paper. What you see later on the paper, you see the spores of a fungus. Those spores, in the forest, they are taken by the wind, they land somewhere on the floor, and there they start excreting enzymes. These enzymes will create a sort of root-like structure, literally the roots of a fungus. And that root structure that you see below the fungus is mycelium. And that is our basic material. That's the material that we use to grow the alternative for APS, for styrofoam. But we cannot do it only with the fungus. We need something else, which is basically the food of the fungus. What you see here is the material that we use today, which is hemp. So we take hemp from Groningen, north part of the Netherlands. That hemp industry supplies hemp to the textile industry, for example in Turkey, or to the automotive. We get the waste, the stuff they don't use. That waste, in specific fiber length and dried until a specific, let's say, RH, we then feed to the fungi. We make a mixture, and that mixture is called a substrate. Keep that word in mind, because the substrate is a word that you will hear a few times more today. So, that substrate is the mixture of the mycelium and the design, the mycelium and the fibers. And that is then filled in a mold. Now let me take an example. We have a customer that comes to us with this glass bottle. Because if you have something sensitive to pack, you need a good protection. They asked me, can you do sustainable packaging for our glass bottle? So together with our designers, we start developing something that is protective but also has a certain marketing value. The end product is then this. But before we get this end product, we have to use our substrate, fill it in this mold. You can see this is just the counter shape of the packaging. The mycelium goes into the mold. We put the mold into a growth chamber, 27 degrees Celsius, 90% humidity, the perfect environment for mushrooms, we can say, and we leave it there for 5 days. Now, after 5 days, this mass of brown fibers has turned into a white product, but still alive. The mycelium is still working on it. It's growing it together. But by then, it will look like this. So the next step is to go back into the factory, take the products out of the growth chamber, pop them from the mold, and then you have this product still alive. To finish the growth, we put it in an oven. Basically, we have built a super big sauna, but a little bit more sophisticated, because you need to get the moisture out. And in that process, we kill the mushroom. Then the mycelium chemically turns into chitin. Chitin is the same material that you may know as the stuff in crab shells. It's also in our nails or in our hairs. So you have something that is completely bio-based, completely natural, made by nature as well. So as I explained, the steps are basically 3 steps. We fill the form, we let it grow 5 days, and we let it dry 1 or 2 days. If the product is bigger, it needs more time. If the product is smaller, it needs less time. So this end product, and you all have some on your desks there, it's a light product. It's pretty strong. I mean, people ask me, is it strong? Well, I say yes, but I mean, wood is stronger But you could compare it with cork if you want to try to compare it to a familiar product. It's very light. It weighs around 100 grams per liter. And there's also a question I often get is, how does it smell? Well, I cannot say. I would say a bit earthy smell, a little bit of the hemp you smell. The mycelium also has its own, but it's not really describable. Try it for yourself, I would say. It has this soft touch because sometimes people say, well, it feels a little bit like a camembert, like a cheese. That also is the case. That's the skin of the mycelium that grows extra strong on the outside. But most importantly, it's light, it's protective. You can protect your sensitive products with that, and it's made by nature. Over here, you literally see the product growing. So this is a time lapse, or it should start. Maybe when I hit the button once more. I'm not sure if that video is working. Try it once more. Well, what you should be seeing, if the video would work, is it turns from brown to completely white, the color of the mycelium product you have in front of you. Ah, yes, it is working now. And this is the process that takes these 5 days. So the products that we make with it, the one that I already showed you, but we do many different things. Much more industrial products like packing heaters, of course, lots of products in the heating industry, heavy equipment, fridges, well, everything that you normally see coming to your home in styrofoam. So a few more examples: glass bottles, coffee cup washers. Cosmetics was our first industry. Now you could say, do you want to pack a cosmetic product in mycelium? If the product is glassware, I would say yes, because it protects. But the cosmetics industry was our first customer also because of the marketing value. I have to be honest about that. People say, oh, this is an interesting new product. Let's pick that innovation and lift our brand. That's one reason why we have been, let's say, allowed to get started. While now, now we see that more and more brands say, but I need to get away from that plastic. Let me find an alternative. So the question I often get is, okay, so how does this work? I have this product. Can you pack it for me? 95% of what we do is custom made. So our designers make a design of the packaging, taking into account all the demands that exist. That demands can have to do with storage, can have to do with logistics, shipping, packing, unpacking, or sometimes even a wish to make a packaging reusable, which means we will make it extra thick or extra strong. When we have the design ready, we will make a temporary mold. We 3D print a mold. We do a trial product for the customer or a trial batch of a few hundred, and then we go into production. And that production means we're going to make X amount of molds. We're going to fill them, grow them, fill them again, grow them, and so on. So it's really a cycle process that we have. Here's one of our first customers in Germany, Maybags, that had a very sensitive jar for pills. And here we have a customer in the UK selling glass bottle candles, very sensitive double-walled glass that was protected with mycelium. Another interesting question, I expect that it will come from the jury in a moment, is, okay, what is the end of life of this product? Well, I would say normally composting. So you can crumble it, leave it in nature. You can even leave it in your own garden because it's good food for your garden. Basically, it's the same hemp that I received from Groningen. Now you can put it back into your garden. But there's more ambition, because those hemp fibers are still the most dominant part in the product. If you look at the little shape you have in front of you, you will literally see the fibers there still. So in those fibers, there's quite some cellulosic content, which means that it could also be recycled into paper. But I think my ambition is a bit too far to say that we can already recycle because we need a collection and separation stream. But in theory, we could. And oh, we're already next to the next one. Yeah, so that was about composting. Then another important, what does your material cost? We're not yet at the same level as styrofoam. We're doing our best. And let me just give you this packaging as an example. When we started, we were roughly 30 times more expensive than styrofoam. So this packaging would have cost 30 euros. Not many customers will come to me for that. I had one or two, but not many. In the meantime, we have reduced that to a factor of 3 to 5. So now this packaging would cost roughly 3 to 5 euros. Actually, we have just changed our technology again because the name of our game is get our costs down, make our product comparable in price to the plastic foams, and we now know that by the end of this year we can make this product for 1 euro. And again, this is our most important objective because otherwise we will not be able to work with the bigger brands. The size or the price is, of course, not only is determined by multiple factors. It's the size. Bigger product costs more money, or will maybe needs more substrate. But also, people ask me, "What if I double my quantity? Will you reduce your price?" Well, essentially, it also has to do with the time window, because in many industries, increasing your quantity makes price reduction. For me, the counter question always is, if you double your quantity, do I also have to double the amount of molds? Or will you give me more time? Because if I have more time, you use the molds more efficiently and the price will go down. So it's a play of quantity and time. We've selected a number of SDGs that we say this is what our business, our company, our product contributes to. Those are the ones. And that's also what literally drives us, because I have to tell you that in the past, I had a wholesale company of packaging, so I literally contributed to more plastic packaging in the world. And actually being active in that business opened my eyes and made me realize we're not doing it right. We need to find smarter ways. And that's what convinced me, this product, that this is a smarter way, a better way, at the same, let's say, for the same, let's say, cost and with the same functionality as styrofoam. Of course, you will know, will ask me, well, what? Because it sounds all well, nature, bio-based, hemp. So what is this impact then? We've done two different analyses. We've done one full-blown LCA, but we also have done a more simpler one, which is the climate impact forecast. And we have an even simpler one that you see behind me. So how do we calculate the impact of packaging? We start with the hemp, and basically the hemp is the only place where we make sure CO2 is captured. Because during the growth of hemp, 1 kilo of hemp will capture approximately 3 kilos of CO2. After that, all the steps, including growing the mushroom, because the mushroom is an organism like you and me, it breathes, so oxygen goes in, CO2 comes out. So all of those steps emit CO2. However, that process is so efficient that if you travel 200 kilometers to a customer, so shipping is calculated at 200 kilometers, we emit 2 kilos while there is 3,3 inside. If you bring it further, the 2 kilos will change to 2,5 or 3. And that's one of the reasons why when we get questions, can you ship the packaging to my factory in Hong Kong? We say no. That's just putting the horse behind the wagon, as a Dutch saying. So a few more examples, but probably there are some questions in the audience, and I'll be happy to answer them. Yeah. Or maybe from the jury.
No question from the audience? Then the jury will take over. No?
Yes, thank you so much for the presentation, for the clear presentation. I have one question on the future. What do you expect to be the market share in the future for this packaging? Because you make this packaging products for specific applications on demand.
Yeah.
And you also said, well, we want to substitute XPS. Yeah. But as we know, XPS is used for many, many products and many televisions, etc. So What is your competition share in the future?
Today, we have a small factory in Zaltbommel, the center of the Netherlands, where we make roughly 500,000 products every year. And that is, I mean, I couldn't even count the amount of zeros you need to indicate the market share, because it's tiny. We are today preparing for a new factory, still in the Netherlands, probably Nijmegen or Arnhem, where we will make 10 million products every year. Still, with that quantity, I think counting your market share is tiny, because in the total, I mean, let me give you one example. A big coffee machine company, what is it, what else? Maybe that rings a bell, is making 2 million coffee machines per year. Those 2 million coffee machines need 4 corner protectors on the top and 4 corner protectors on the bottom. That's 8 corner protectors in total. That makes 16 million corner protectors, and my new factory can do 10 million, the new factory. So in terms of market share, it's difficult, but I can tell you the philosophy. We want to build this new factory in the Netherlands. After that, we will quickly go east and south, where there is production. Because that's where TVs are produced, that's where coffee machines are produced, that's where heavy equipment is produced, and that is where we will need to build and develop the factory. But not only that, that's also where there is lots of organic waste. Because one of the reasons why we want to go local is because over here we have hemp. But if you go to Portugal, there's cork. If you go to Bulgaria, there's a lot of lavender. And all of those waste streams we can use to grow these items.
And do you want to keep the technology within your company, or are you willing to sell the IP or whatever to other countries, other companies to expand the principle of using this packaging technology?
So basically, there's 2 elements in our expansion strategy. The first one is go local, and that not only means using local waste streams, but it also means working with locals, because those people in those countries will know their markets much better than we do. So we will have to share in order to grow quickly. Absolutely, and that means we will share our technology and IP as well. Yes.
Can you repeat again why you cannot recycle it together with paper? What is the percentage of the fibers in it?
Yeah, so the reason, well, actually, your question is why can you not recycle it with paper? Actually, I think we can. I think we can put this in the paper bin, but I'm not sure, I don't want to tell the people today, put it in the paper bin without me having done an analysis if it may cause disturbances. Because there's hemp in here, and the hemp has enough cellulosic content to function as paper. But just like where you have grass paper, you're not going to ask people to put all their cut grass in the paper bin. This is the same for me. So it's just a matter of knowledge and time.
Yeah, interesting. Okay.
Any last question, maybe? Yep.
A question? Oh.
Hi. Just a simple question regarding the mold.
Yep.
It looks like plastic. It probably isn't or is. How do we deal with that? Because if you want to expand, you need more plastic, more molds, etc.
Yeah.
How are you going to deal with that?
Good question. Because of course we want to get the plastic out of our factory as much as possible. But we have tried so many things to use as molds. Gypsum does not work. Too much moisture loss. Wood does not work because the fungi is a wood-eating fungi, so it will eat my mold. So plastic, recycled PET is the way to go for us. So okay, then we've said, how can we soften that? So what we do is we've invested in our own thermoforming equipment. So we CNC cut the shapes, we then thermoform the plastic. All the molds that are damaged, because over time we tap them on a table to make the product come out, and sometimes it breaks. We put them aside. They go into the recycling stream, and once we're big enough, we will get those sheets back again to thermoform again. So it must become a closed circle.
Okay. No question from the audience. Thank you very much for your presentation.
Pleasure. Thank you. Yeah.